Hi, my name is Andrew McLaren, and I want to talk to you about the To Thin and Not to Thin project, which is a Radish experiment where we thin half of them and we don't thin the other half in this plot, and we try and see what the effect of that is. And different groups measure different things. So it's an outdoors lab experience designed for an NGSS performance expectation, but it's honestly more like a big picture, all the various practices when you do science kind of thing when we were talking about this project. To help you kind of see the final product, I had some groups that did these photos to show the thinned and not thinned. You can kind of see just visually that these guys have not been thinned on the right, and on the left side, they have been thinned just by the density of them next to each other. And then we had some groups like doing written observations as well as measuring the weight of the thinned and not thinned harvested radishes. So we like cut off the greens, and you can kind of see what we saw here with the not thinned and the thinned. Like the thinned ones were actually bigger. There were less of them, but they were like bigger by mass. But when you looked at the total weight, it was fairly comparable. And the not thinned actually were a little bit like there was actually more mass one year that I did this. And different years might get slightly different results depending on the exact conditions, right? And then we had other groups that were like measuring the height and they graphed it out like this. And they provided a little bit of data. I think that this might have been different than their heights. I'm pretty sure. But it might actually be their heights. Some groups did like distance between two radishes. So they're trying to get like the average of that or like number of leaves. And so there's all these different groups doing different things. And it was really interesting to have the students at the end present and kind of talk about what was similar and different about those ways of measuring the effect of thinning and what we were really trying to get at. So it was really, really neat. So for the rest of this video, what we're going to do is kind of talk about why this is such a good lesson series, give you some context as well for how this was made. And then I'm going to show like basically everything off the lesson instructions, resources, and examples of the student work. All of that will be in a Teachers Pay Teachers product that you can buy. It's kind of like a bundle, but it's a single Google folder that I put everything in Teachers Pay Teachers. So I liked to have these things organized by examples, lesson plans, and resources. Unfortunately, for Teachers Pay Teachers, it's all in one gigantic monster folder. So I tried to give them little prefixes to help you understand what you're looking at. And then also ideas on how I might go about improving this or aligning it more to different aspects of the NGSS. So at its core, the series of lessons has students actually doing science and the various stages of that process, kind of switching back and forth at sometimes, but it is a fairly linear series, so it does kind of line up with that scientific method that people previously used to teach before the NGSS. And I really like how this has real data that the students are collecting in the garden. And there's a variety of different methods of looking at the same thing to really get at like what, when we change this one variable, the thinning, what does that actually do to the plant? And we can look at tons of different aspects to understand that in a better way. So this also is going to have students using a lot of technology to present their data with how I did it. You could do this without Google Slides, though I'd highly encourage you to do that, as well as Google Sheets. It's just nice having it all backed up on the cloud in case something happens to their packet or they go outside and things get wet. Paper is pretty good most of the time, but when it's not, it's really bad, right? And then there's also this final stage where they're engaging in this discussion or consensus making. And that was really, really interesting for me to go through this whole process with students. It is kind of a little bit awkward in some ways, though, and you'll see why, because you're kind of doing this group measurement. Like one group goes out and does measurements, and other groups are not doing that at the same time because you're all looking at the same plot. So there's some aspects of this that are less than ideal, though you could take this idea and do this with things inside of the classroom where you're thinning and not thinning some crops and some planters in the classroom. I really liked doing this outdoors in the same bed. it was just more authentic to me having them actually be gardening and seeing why we actually thin things out. And it came from this question of, well, why do we do this? And oftentimes students are reluctant to thin plants because they feel like they're killing them, and it's somehow bad for the plants. So it's good for us to look at, well, there's a difference in the yield here, and how is that different? So yeah, it's a pretty cool series. So to give you some context, this lesson was developed in partnership with the grant project through the School Garden Project. I heard about that from Mandy Redmond, another teacher from my teaching grad program, who told me about this grant opportunity during the summer where we could work together with other teachers and share ideas around lessons that we could do. And then we even got paid a little bit to develop these lessons. Unfortunately, that project ended up being abandoned before they were published on the website. But there was a lot of really good work and cool collaboration with all these other teachers who were mostly elementary school teachers who wanted to just find ways to use their school gardens. But there was a couple middle school teachers in there with me as well. And we were talking about how can we really get students doing like an authentic experience in the garden. And there's a lot of resources when you go and look at garden teaching where it's like, here are the plant parts, let's do a plant dissection. And it's very direct instruction. And I wanted to change that. And Courtney Stitt, this other teacher who was a middle school teacher in Eugene, we were talking about this idea of thinning and why we thin and how students sometimes have issues with that, and kind of came up with this idea, the original idea together, and developed a couple of the parts of the lesson plan. And then throughout the next 2 school years, I worked mostly with Amarina and Elizabeth the first year and mostly with SK Gaskell the following year to actually do this project, as well as my teaching assistant, Mary Kale, who was huge in actually getting students out there and working with them consistently in their groups. So that's an element of these lesson plans. It's really hard to do just by yourself, but you are doing this like once a week. So if you have early release days, that's perfect for this. And if you have a TA, that also works out well. If you've got like a parent volunteer, really, really useful. So this project is kind of mine, but it's also largely connected to these other organizations. I did also get permission from the other teacher to put this out there and also put on Teachers Pay Teachers. So I just tried to make sure that I had the copyright rights to this. But I did want to help people understand how this was made. And it wasn't really just done in isolation, like the best things in teaching. It was made from looking at what other people were doing, seeing other garden spaces, talking to them about what their experience was in the school garden. So yeah, there is a ton of different resources that I have to support you doing this yourself, including lesson instructions and various other resources like examples of student work and an overview of the timeline. All of that's included in my Teachers Pay Teachers product. I'll put that link in the video description so that you don't have to copy this down. But that is the Teachers Pay Teachers link right there, which will take you to the product there. And I'm just going to go over what's actually in the folder on Teachers Pay Teachers so that you can just see the whole thing. If you look here, there's a couple lessons like the write-up going over the summary and background, which is mostly the same for the lessons, but then there's like what materials you need and what you need to do to prepare for it, as well as a written procedure on like what you could say to help them get started and some strategies for helping them discuss and doing a little gallery walk. Basically, what you have students do is you come up with different ways of things that we need to control or like the effect of some plant growing. So like if the water varies, that might make some plants bigger or smaller. So we need to make that be consistently the same. And then how we're going to actually go about measuring the effect of thinning. And there's a couple things that kept on coming up with different groups, like measuring the height of the plants or doing written observations or maybe measuring the weight of the plants, which you can't really do like each week. So that's only done at the very end. Broadly speaking, there's 2 main types of measurements, the ones that you do weekly and then like the summative final measurement. And it's kind of hard to get like the circumference of the plants until you've harvested. And we only had them do, I think, the circumference of 10 plants, or like the average of like 10 plants. So they were randomly selecting that, which was okay if they were doing it randomly, but not if they were just going for the easiest ones, because those would skew to being like taller or bigger. And so that caused some issues when we were doing some of our average calculations, which was good for us to discuss when we were looking at different groups throughout the different periods, right? And then basically that first lesson is just kind of setting them up to understand the idea of the experiment. And then there's another lesson, um, going over like, okay, now let's get you into your groups. And there's various group folders and a little printout for them to use, um, so that they were able to record data in the field. So they had to write out a little procedure and like how they were going to record the data, and then actually record the data in either this data table or like in this extra space that they had on the packet. There was some data that wasn't appropriate to put in the table, so they had to sometimes put it at the end if it was like written observations that didn't really work there. So they might need some other paper to do that, but they need to keep it organized, right? So there's a ton of different things where they're actually engaging in like the science process of recording data, conducting investigation, having good instructions in case one of them's absent. The other ones need to be able to follow it. So there's quite a few interesting things just going on from the beginning. And you do need to plant the seeds, of course, which you can do a little bit with different classes, but it's best to have this be done consistently. So it's ideal to have the same people kind of doing the same thing, or at least the same adult guiding them while they're going and planting some of these rows out. Um, Again, good to have consistency, and the kids can kind of learn and see that through this element here. Because if they mess that up, things are spaced differently between the two rows, it kind of messes everything up, right? Then we also had the next lesson. This is kind of like the recurring lesson. So I've got this marked as like 3 through question mark. Depending on where you live, this might be like a month long where you're going out each week, or might be 2 months long. I think for us is a little bit over 2 months. I think we might have had snow both the years that I did. So it kind of made it so that we didn't even see significant growth um, until over a month after. And then it took like another month or so for them to grow to being harvested. So that, just keep that in mind, that you're going to need to have consistent, at least weekly measurements. And if it's not the same day, well, it's going to be important to mark the numerical day, because it might be different days that you're going out different weeks, and you don't want those spaced out perfectly, even if you're doing a graph of those different days. So just be aware that there's some elements of going like and displaying the data where you have to really support them and helping that understand like how to set it up. And so then yeah, this is like I had one group go out and do the measurements, and I also had the other students doing another task during that time. And so there was like a TA that I would have that would either go out with them, or I had my nonprofit. They would come out once a week and go out with the students for a little bit of time and collect data with them. And it took quite a bit of time. Like each group might take 5 to 10 minutes, but oftentimes especially the first time they do this, it needs a little bit longer. So it's pretty hard to get all of the groups through in one period. Just be aware of your time with that. And if one group's taking too long, too bad. The other group's got to get out there. So if they're messing around, they're gonna miss data that week. And then there's the final piece here when there's presentations that they're going to need to do where they're presenting their findings. So I gave them a little set of prompts here, and they needed to make slides. So there's like a Google slide expected assignment for them to do. And basically there was a couple prompts. They needed to answer that, and then the other groups would come in and see them present. I was thinking that that worked pretty well, though I might tweak how I would do that in the future. And essentially, this is the like final review. Like you're going to have students making their graphs and then presenting. So that's like 2 days, most likely, maybe even 3 if you want to spend a good amount of time explaining things after those presentations. But there was this little plant space game that I got from the school garden project around them gathering resources and having there being like thinned students and not thin students trying to play the game. And so they can kind of see that and then relate that to what we saw in our data results. So there's like all those various lesson plans. And then I've got like student work because I wanted the students to put the student work in a little data table and get used to working with data tables in Google Sheets. It's a good skill. It's also more reliable in case the paper copy gets damaged or whatever. And you can see that these students, they had to put the day number here, and that accounted for things pretty nicely because we didn't go every 7 days, not exactly. So yeah, works out pretty nicely if you do it kind of like that. You're gonna need to support them with this. The videos that I did became like outdated pretty quick because Google Sheets has had a couple of changes recently in how data is displayed. But you can get the idea of how they were doing this. And then there was like the averages being automatically calculated for them because I was working with sixth graders. I was just like plug in your numbers and I'll give you the average, like not a big deal. So there's some elements of what you need to do there to help them out. Then those slides that I kind of showed off earlier in the video, you can kind of see the final product that they presented with their names removed, of course. So yeah, there's a ton of different things I've got in there. And then there's the resources or printouts that you would need for the students in addition to the lesson plans, like that uh, thing for them to collect the data in, a little lab journal, and a overview for you. Also kind of good for the students as well for them to understand the general structure. But this was more for me to help myself understand what was happening on what days and what the sequence was, and the presentation prompts. Ton of different things. I currently have this on Teachers Pay Teachers for $10, which is, in my opinion, quite a steal, pretty good deal. So yeah, I hope you like it too. But I think that that's a ton of different stuff written out in quite a lot of detail to help you do this lesson yourself as well. So I was looking back at this lesson after not teaching it for a while. I actually went to a different school that didn't have a school garden, so I had to kind of put this on pause. But I was looking back at this, and the performance expectation is really about having them constructing an explanation from some data set. So you could reuse data sets from previous years and have the students look at those various graphs and have them draw those conclusions. So you could probably reduce this whole thing down to like 3 days or so if you were to just focus on that one particular practice. But if you like the broad approach of having students doing science in the classroom, which I really do think that's a good approach, and it interconnects with so many different parts of the NGSS. It's more of like a scientific method and practices focus where you're covering all like the 8 parts of the practices really. So if you wanted to do that, there are some things that you could do to make this actually have some points in some parts that aren't really counted as like points, and therefore students don't value it as much. And I would really say the procedures need to be scored. And so I have a whole video on how to score students' abilities to design and conduct an investigation. I pooled some expectations from that, and also equitable grading. You don't want to have a group project where everyone is responsible for the whole thing. So you can grade student A on the procedure if it has like independent, dependent variables, and student B if there's like no tools and how the measuring was done. If that's not explained, then student B is going to be getting like a 0 for that part of the project, right? So different students have different responsibilities for different parts of the project, and you can then make sure that procedure is scored in a way that's fair and it doesn't penalize one student for another student not doing their job. Though I bet some students are going to want a good procedure, so they're going to help each other out anyways. And then there's also this ability to actually conduct the investigation. They need to have like a good data table and figure. They need to do things like making sure the methods are actually done correctly. So you're going to need to observe them at least once doing this data collection. And then student B needs to make sure there's enough data. So if there's like 10 data points that need to be collected each day, if they're missing some on some days, then that's less than ideal, right? And so you can have them responsible and having scored feedback on different skills throughout this process. And I was thinking that you could do like a CER format at the end here, which if you look at the prompts, that kind of is what they're doing there. But if you wanted to have this be scored equitably, instead of having everyone have the same grade, you could say, okay, there's a CER. A and B, you need to focus on the evidence. C and D needs to focus on the reasoning. And you could even split that up further with different parts of the evidence, like what is the data and how was it collected. And D would be like what key concepts were related and what vocabulary is related. And so you could have like different things where you're breaking it down for them further like that to get more precise feedback around certain skills, which if you're doing standards-based grading, you can then just plug that into your structure for the year around those different practices. Yeah, I hope that you guys enjoy. I think that this was one of my most authentic experiences. And some students got kind of tired with it by the end because like we've done these measurements so many times. But there is something that really stuck with me throughout the years and with students as well was like this is the one time that they really do science, and there's a lot of times that they just get given the facts, and this is an important element of giving students feedback so they know that they're doing like actually good at science as opposed to just memorizing a list of facts. Yeah, thank you. Thank you for McLearning with me. Before you go, please check out the following services that I offer with my business. So if you click the link in my videos, this goes to my website. I might be changing it from Podia because I'm no longer doing the interactive videos for sale. I might put those up for free. But most of my other services are linked here. So you can see that I've got like a Teachers Pay Teachers and a Wyzant. The Teachers Pay Teachers has a lot of my assessments that I have for like the NGSS, as well as lessons that I made when I was actually a teacher in the classroom. So I've got quite a few things like CERs and other things on there. If you want to get one-on-one live support from me, either like with science or like working on like teaching support lessons and that kind of stuff, you can sign up through Wyzant. I have a link to there where you can contact me there, and we can schedule hourly appointments. And I've got a few other things on here like a Facebook page and other social media. And if you're interested in getting professional development with me for like a team of teachers, a whole page with information on that. So yeah, feel free to check that out. Thank you.